So now I also want to give it a material, so it looks a certain way. For that, we obviously first of all need to create a material. So we can right click here and create a material. And we're calling this wireframe because this thing should not actually be looking good. It should just visualize us what then the geometry combine, the combine will combine for us, and we give it a proper material inside here. So we just want to like visualize it nicely so we can work with it, not make it look good. So let's open it up. And in here we did some light materials earlier. We simply only want to display its raw color. So if we select this here, we have the settings to the left, and I want to change it from default lit to unlit, meaning we only can show the pure color. So if we now right click here, so if we now press 3 and click, we can create ourselves a vector 3, a color, right? If we double click, we can create a color. Let's keep it black for now, and we're going to plug this simply inside here. Apply this and save it. So how do we get this material on the cube? Now, the obvious way would be selecting it, and here it has a material, and put it on. It would be black. But we're not going to do this. We want to always, for every geometry, give it the same material. So we're going to do this actually in the blueprint in the child here. Let's make ourselves a little bit more space by dragging this stuff back here. We know this is our box. This works. This is all good. Box, draw. Yeah, well, whatever. And down here with a sequence, we can just, after we trigger the box, do something else. Make a reroute, enter. We can just drag out here and set material. And it will automatically connect this thing here, this here. Yeah, it's the same thing. Because this here contains this here, and it contains the mesh. So this is the add-on thing. So we're saying this add-on thing with the mesh inside should have this material. We can select the material here. So if we now press Control Space, you can open the bottom bar. You can see I'm in a wrong thing here. We could select it and click on this arrow. You can also just drag the window aside and do the same thing. Select it here and then click the arrow here. It's just pretty handy in Unreal 5 that whenever you're in here full screen, you can just press Control Space bar. And if we now compile this, it will be black because we set the material right here. Though we want to modify the material a little bit more. Let's go back to the material, select the node itself, and somewhere in here, I don't know exactly where, I'm just going to search for it, wire. And there we can check wireframe. And if we now apply this, we only will see the wire. Now I will have multiple different things for the wireframe. For example, for the subtract should have another color and the collision should have another color. So what I'm going to do is I'm going to right click here and create a material instance. A material instance is essentially a direct copy. It will not be much more, you can say it's not more efficient in doing that, yeah? Like performance-wise, it's not more efficient. But the thing we can do, if we go to the parent and we right-click our color here, we can convert it to a parameter. And we can name this color, yeah? If you messed it up, you can just select it again. And over here, if you delete the wire out of that, you can also change the name in the settings here, because this node's settings are here when it's selected. So with that being a parameter, and with us created a new material instance, we can open that up and we will see that we have, actually, where is it? All right, we need to apply it first. So with that applied, with that right clicked and made into a parameter, here right click, create a material instance. So we have a new one. Then we can change the color here without always creating a new one. Just performance wise, it's not more efficient, but you can workflow wise, make it more efficient for you by creating material instances. So, but this thing is still black because we applied this one here, but I want to apply this one here. So I'm going to select it, go back to my child and put it in here. And now it will be whatever color we set. It should at least, right, compile it. So I want to give this though a strong green color. Let's make this one green. So it's as visible as possible. There we go. All right, let's close the materials. We have now set a nice material to it. Let's create ourselves a new folder here, and we're going to call this geometry. All right, we're going to grab our geometry and put it inside here. So with that, we have a geometry which we can already create, right? Let's close all of that here. We have something which we can combine the geometry we're creating, and we have the actual geometry which we can like, well, move around. If we, for example, would want to create stairs or something which we want to combine, we could inside here create another child, which we might do later. You could rename it, and then inside here you could, like, just as a quick example, rebuild, right? And then you could like stairs, append stairs, and you could create this here just as a quick explanation. I'm going to delete this again. For now, we're just having a box. We also want to subtract something. So when we create a box, we might want to cut it up or something so we can create another geometry. So we're going back here and we're going to, let's right away create a new folder and call this subtract, all right? And we go inside here and we're going to create a new blueprint, dynamic mesh generator, actor, select. And I'm going to copy the name once again, just so I have a nice name structure here. And instead of geometry, this one is going to be subtract. All right. And right away, create a child of that. And instead of parent, this is going to be child. So, and I'm going to give it a 1 in front, so it's nicely parent child. Let's open it up. And all I want to do here is exactly create a box again. So we're going back here and open our geometry, open our child where we actually create this box. And I'm just going to plainly copy this. Go into our subtract child, paste it in, and I need a rebuild here as well. Plug this in. And you're going to see this variable and this variable are gray. The reason for that is because we copy them, but they are not actually created. So we can right click on them and create them. Oh, they're here. And now we can connect this here, and same thing here, right click, create variable. And now the thing is though, we have to compile this and we have to do this manually. We have to manually make it instance editable so we can see it right here. And we have to manually show 3D widget so we can see it inside here, and we compile this. Now, if we go back to our subtract, drag in the child, we forgot one thing. We also have to give it the default values again. So 50, 50, 50. Compile it. And if we now drag this child in, we're going to have the exact same thing here. Now it's also green. I don't want it to be green. It's a subtract. It's not a geometry. So we're going to change the color. Let's go a step back where we have our materials, and we're going to right click on our main material and create a new instance. We can double click that and we can change the color. Let's say in this case, we're making it a strong blue. Okay. And now, since this is another material, but we still have this one on there, we need to go to our subtract, where we set the material and change this and compile it. And now you can see it's blue, it's green. Green means geometry, blue means subtract. Now I didn't put this in the right folder. Let's put it in the right folder. All right. So, and what in theory should happen now is if we move this around, this one will cut out from this one here, and the combine will handle that for us. So we have two boxes. We have a box for the geometry, we have a box for the subtract. Now we just simply need to combine it. Let's close all of that here, and we go into our combine, because the combine should handle that. We're going inside the child here, and we're going to make this big and think about it. Now, first of all, we want to create a variable here, because this is the actual object in which the mesh then will be. So we need to think about this. How do we actually now get our subtract and our geometry? We have to get it somehow, right? We have to know that it's there. Now, the first thing we can do is here, get actor of class, get all actors of class. What an actor is. An actor is a thing inside the viewport, right? Inside here. An asset would be something inside here, because you can have multiple actors of the same asset. So if I drag in multiple childs here, subtracts in here, it would still be one asset, but it would be multiple actors, all right? So this is the difference. And this is why we want to get all actors, all of them inside the viewport. Let's plug this in here, so it triggers. Now we need to know which actors we want. Now, if we think about it, let's go actually to the geometry for a second here, because we are starting with that. We can ask for all the parent actors, because if we ask for the parent actors, we will also know about the children which we created from that. If we only detect a child, it will only be this one. And even if we created multiple ones, it will only know this one here. So we're detecting the parent And even if we only drag in the child, it will know about it. If we drag in another child, it will know about it. So that way we can create multiple different geometries and still detect them. So we can just simply select it and click on the arrow here, or you can just look for it, subtract. And I have a few ones because I did tests, right? So I just select it and click on the arrow here. With that, we will detect all those things inside the editor. Now we have a weird thing here. We have a few dots here, right? This here, you can imagine, let's take a quick look here. If we create a new variable, anyone, it does, any kind, it doesn't matter. It's holding, let's make a vector just to visualize that. It will hold something for us. It doesn't matter, right? But it will only hold one thing of that. But we can make this into an array, and now it can hold, compile, it can hold as many as we want. So if I click plus here, it holds one letter. If I click plus again, it will hold 2, 3, 4, 5, 6, etc. Let's delete this again. Same thing here. This is an array, so it holds multiple things at once. And what does it hold? All the things we dragged in. If we now make a for each loop, I know, scary, many outputs, not really hard to understand, honestly. And we connect this here. This thing will trigger for everything we give it. So if we have one of the child geometries inside our editor, it holds only one and it will trigger only once. Then it will complete. If we have 15 in here, it has 15 in here. So this for each loop will trigger 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? 15 times, and then it will complete. This is how it works. And this thing here, the array element, will give us always the one we're currently on. So we have 5 of our geochilds, so it holds 5 of our geochilds. It will trigger once, it will hold the first one. It triggers again, it gives us the second one. Third one. And the array index just is an index, meaning for the first one, this number will be 0, for the second it will be 1, for the third it will be 2, for the fourth it will be 3. So it's starting with 0. It's just a number that tells us on which execution we are, on which loop we are. Are we on the first one, are we on the second one, whatever. And once it's through all of the ones we gave it, it will trigger the complete. And now we can just, to show if everything works, we can drag out here and print string, and we just can plug this in here and it will print the name of the thing we're on. If we compile this, it will print our geochild geometry. If we drag in another one and we put this, let's just put it into the folder for now and compile it, it will print us 2 because it will trigger for every one we give it. Now the problem is, when we have multiple objects, right? We have a room, we have a door, we have whatever. It will also trigger if we are outside of it. So if I compile this, it will still print 2. But I only want to be specific about in which folder we are. Why? Because we currently have a room here. But what if we have another whole folder structure which tells us it's a door or something, right? So we need to specify, we want to get all of them which are inside the right folder. Meaning, our geometry as well as the subtract, they work very similar, the subtract and the geometry in this case. So I'm just talking about the geometry for now. So here where we loop through each one of them, we want to check, are they in the right folder? But before we can do that, we need to know in which folder our combine is, right? So we have to combine in here and we want to know that it is inside the room. So for that, before we do any of that, we want to know which folder our combine actually is in. If we know which folder our combine is in, we can also say only interact with those which are in the same folder structure. So for that, we have a node here, right click, get folder path. And this specific node refers to the folders up here, not to the folders in the content browser. They will refer to this one here. Now this here is a name. There are 2 types of variables that display letters. Yeah, it's first of all a name, and the other one, if we print string here, this is a name and this here is a string. Both are just letters in a row, more or less. I think a name is like a set thing, while the string actually knows about the individual letters. Doesn't matter, it's just both words and letters in a row, whatever. The thing is, one gives you some options, the other one gives you some other options, whatever. But we want to convert this here into a string. So I'm just going to plug this in here into the print, and voila, now it knows about the individual letters. So if we disconnect this here for a moment and we work with that now, and we print this out, we're going to see the actual folder path. So let's print this, compile this, and then we see room. Actually, let's make this a bit longer. We can unfold this here. Let's make it 15 seconds or something, whatever. And main room / combine room, because we are in the main room / combine room. All right. With that, we know its folder location from the combine. We're working in the combine and we're printing the combine main and then combine room. Now we want to separate this because we want to know which main we are on, so the room, and which we are on here. And we want to save this name as a variable, so we can just nicely reuse it. So right click here, promote to variable, and we're going to call this full folder path. All we do here is, well, save it in a nice variable. We could also make strings everywhere, those connectors everywhere, but this is just much easier and cleaner. Now we can take the full folder path again, because we still want to work with that. And again, if we print this, you can see we have a main room / combine room. This is how it displays it. First the first folder / then the other folder. And we can just simply drag out here and type in string. Now there are a lot of string options and most of them are very easy to understand. For example, chop the right, reverse it, replace something. But what we actually want to do is split it. And here we can give it something it should split it by. If we just split it by the slash, it will output a left and a right based on the slash. If we now print this out, and right before it was main room / combine room, and if we now print only the left from the slash, it will only print us the main room. If we print only the right, it will combine room. So but now we want to actually know about the object we are in, so only the room. We only want to know about the room currently. We're going to split this again because you see we are having an underscore here. This is just how we wrote it. So if we split this again, actually use the parent here, using the parent, and we want to split this now by the underscore. And if we print the right side, we're going to end up with only room, and we know which object we are on. Now we're going to save this also in a variable, right side, promote to variable, and we're calling this struct name. You could also call it object name. It will essentially just print from this folder the name in the back here. Now connect this, because there's a nice space here, something like this here. So what do we have here? We have the full folder path and we have the struct name, so our object name. But we also want to know, is it in the combine? Is it in the geometry? Is it in the subtract? Which folder is it in? And we already sort of did this here, because if we print now again the right side, see what happens. What does it print us? It prints us combine room. So combine room. Yeah, but it still prints us the room, which we don't want. We only want to know, is it in the combine or something. So we can just drag out from here and replace the name, because we already have the name. Yeah, here, struct name. We can just simply replace that part. So let's actually grab it from here, struct name, and replace that part from to just simply nothing. And if we compile this now, we get a combine underscore. Meaning we have now a few informations we can work with. Actually, we should probably also make a variable out of that. So let's right click here, promote a variable, and this is going to be own folder. And we have a few information now. We have the full folder path, we have the name of the object we're working in, and we have the name of the folder we're currently in. And that way we can determine, is it the same name and in which folder are we? So let's plug this back in here. And here we're working only with the geometry, right? It's a bit hard to see, but what we put in here was the geometry. And we want to get all of the geometry, which we're currently doing, looping through them, doing everything, doing something for every one of them. But we also only want to do this if they're in the same folder as our combine, and if they are in the geometry. We essentially need to do the same thing we did here, but instead of using itself is the combine, we want to use the geometry, which we get here. So I want to take a look. If we get the folder path, copy this over here. Currently self, it uses the combine, but But if you drag this in here, it will use all the geometry we detect here. And we can do the exact same thing we did here for the combine, just for all the geometries. So we can just simply copy that thing here, paste it over here, yeah? And we need to replace the variables now. But before we do that, I want to sort our variables here because we're now going to add a few more and otherwise things get a little bit messy here, all right? So I'm going to click on that here. And here we can give it a category. Instead of the default category, I'm going to write it folder path combine, yeah? And now you can see it created a separate category. Those are useful for more things than just sorting things out here, but let's just do it for here. I'm going to grab those in here, all right? We can fold this in. We should probably rename those though. Let's just F2 this and write a combine in the back so we know those are actually specifically for the combine. And you know what? Let's just copy this here, Control Z, Control V, Control Z, Control V, Control Z, Control V. And instead of combine, those are going to be geometry. All right, and we're going to also make a new category for those. Folder path geometry. And I can drag those in. And all we need to do is now replace those variables with our new ones. This is the full folder path combine. So full folder path geometry, set, and replace it. Delete this one. Here we're using the full folder path combine. So full folder path geometry, get, plug it in. Struct name combine, struct name geometry, set, delete it. Struct name combine, struct name geometry. Own folder path combine, own folder path geometry. Plug this in and connect them. And we can move this up here. And instead of itself, like I said, we're going to use the actual thing, the actual geometry. And we can connect this here. So now for each geometry we added, we will detect all those folders. Meaning we get the full information of the folder path from the combine, and we will get the full folder path information from each geometry. Now we just need to compare them, and we only want to continue if on conditions if they are in the right folder path, etc. So there is a branch, B left click, and you will get a branch, and you can see it's true or false, and we only want to continue on certain conditions. The conditions are if the struct name, so if the room, yeah, if the object name here is the same, only then continue. So we're going to get the struct name of our geometry and the struct name of our current combine. We only want to continue if those are the same. If they are in the same object here, room, both have room, and we can just exactly equal exactly the same, and you can hold the mouse over it. Test if these input strings are equal. If both are equal, this will spit out true. Does it spit out true? It will combine. It will continue from true. If not, it will just do false. But there are a few more conditions we want to do. So let's print out here from true. And what do we want to print? We want to print out, well, the object we're currently on. So let's just connect this in here. It will print us the name of the object we're using. And you can see it will only print us those two. Yeah, the two we have in here. What happens if I drag one out now? Just drag it out here. Call again. Oh, it will still print true. So now this should work even though we have one outside, but you can see it's still printing both. I'm not quite sure why this happens. To me, it makes no sense, but we can fix that. If we take a look here from the full folder path, right? If we print this out now, you can see one is none because one is outside and the other one is like inside its folder, right? But as soon as we print this guy here, the struct name geometry, it prints both, which makes absolutely no sense. How does it get from none to like room, right? It makes no sense. We can simply fix this up here after this one here. If we make a branch and we check if this variable equals not exactly none, it will print none if it's in no folder, And if it's not none, then we can continue. So, and if we now print, or just print hello, right, we can see how many times it triggers. It will only trigger once. Yeah. If we don't do this, we'll print 2 times for both outside, inside. So with that, we can check, is it actually right?